This is going to be a really quick lesson on isotopes and writing symbols for those isotopes and ions. So to start with, I have an example of arsenic, and I've given you arsenic 92, arsenic 64, and arsenic 75. These are all isotopes of arsenic. Are they the most common ones? No, but they are isotopes of arsenic. Now, what I do want you to notice is that when you're looking at the periodic table and you find arsenic, it has a mass of 74.922. That tells us that the most common isotope is probably somewhere around this number. Of course, there are exceptions, but for the most part, that is true. So if we have an isotope that has a mass of 92, we can write it like this, like I've shown you here, arsenic 92. Or you can write it out with its name. Okay, these are both showing the same thing. Another option is to write the symbol, and then when you have a symbol where you're writing the isotope, we talked about this a little bit in our lesson over the atom, the top number will be the mass number, and in this case I will have to give you the mass like I've done here, or you will have to know the number of neutrons and the number of protons, and you can add those up to get your mass. The bottom number will be the atomic number, which you can find on the periodic table. The atomic number is equal to the number of protons, so if you know the number of protons or you know the element, you can find this bottom number right here. So when I find arsenic, here it is, it's number 33, so that bottom number is going to be 33. Okay, so those are different ways that you can show the exact same isotope. So try an example with number 1. Okay, the second type of concept that I'd like you to understand is using that symbol when it's provided to you to find the number of neutrons. And here I've given you an isotope of iodine, iodine 127. So the top number is the mass number. I've provided that to you. Notice it's not a decimal. That's because I'm giving you one single atom. You only have that decimal like you see here, the 126.904, when it's the mass of the entire element. For an individual atom, you're going to have a whole number like you have here. The bottom number is the atomic number, which is equal to the number of protons. All right, so if I know the mass, and I know the mass equals, for an atom, the number of protons plus neutrons, and if I know the atomic number, which tells us the number of protons, I can take that mass number, the top number, and I can subtract the atomic number, and that will give me the number of neutrons. And so in this case, when I subtract 127 minus 53, that gives me 74. That means that this isotope of iodine has 74 neutrons. Okay, so that's how you find the number of neutrons. In number 2, I want you to try 5 different examples where you are going to subtract to find the number of neutrons. All right, in this next example that you're going to do, and you're going to do these example problems here, number 3, you're given an isotope. Now in this case, this isotope is different because it has a charge. And this is telling us I have a calcium 40, so the mass of the atom is 40, and it has a +2 charge. When you were in your physical science class, you should have learned that when an atom gains or loses electrons, it forms these charges. Now keep in mind the number of protons will never ever change. Okay, and that is based upon your atomic number. So when you look at calcium, here's calcium, the atomic number is 20. I also gave it to you. And so that means that we have 20 protons. Okay, and it spells out P-E-N, protons, electrons, neutrons. Now, in general, the number of protons will equal the number of electrons. That's assuming it has not lost or gained any. Now, we wouldn't say that it gained 2 protons to have this charge because that would change the number of protons. Changing the number of protons changes the identity of the element. And this is calcium, so it has to have 20. The plus 2 means that it has not gained electrons, which are negative. It means it lost electrons. It lost negatives. Electrons are negative. So it lost 2 electrons. So where it would normally have 20 electrons, it lost 2. That's why it's a positive 2. And therefore it has 18 electrons. And we're going to be doing some examples where we look to see exactly why it loses 2. Why is that happening? Okay, so if you see this charge, if it's a positive charge, it lost negatives. It lost electrons. If it's a negative charge, so for example, if you had X and it had a -3 charge, that would mean that it has 3 extra electrons. That would mean that it gained 3 electrons. Okay, so positive means it lost electrons. Negative charge means it gained electrons. And the number of neutrons you're going to solve, just like we did in the last example, the top number is the mass, which is the protons plus the neutrons. Now remember, we don't count the number of electrons because the mass is so much smaller than that of a proton and neutron. It really doesn't count for much. Is it still there? Yes, absolutely. But it doesn't make up much of the mass. Therefore, we don't include it. Now the bottom number is the number of protons, which equals your atomic number. 40 minus 20 gives us a total of 20 neutrons. Okay, this is a coincidence that you have 20, 20, 20, and then of course it lost 2, so it's 18. So keep that in mind. The protons and neutrons will not always be the same. Is it possible? Sure, but not always. Right, so that's how you find the number of protons, neutrons, and electrons in any given isotope or an ion of an isotope. All right, for the last type of problem, you're going to calculate the mass of your element. And you're going to do that from the percent abundance of its isotopes. Now, a lot of times when you get the mass of the isotope, it'll be really close to 37 because it's what we call our AMU for the element. Many of the examples will have it at a whole number. So use whatever I give you for the isotope along with the percent abundance for that isotope. So when I'm looking at this here, it tells me that 24.47% of my chlorine isotopes are chlorine with a mass of 37. Okay, that's what that's telling me. And it's telling me 75.42 of those are chlorine 35. Okay, many times you have more than 2 different isotopes, but in this example, we only have 2 isotopes to worry about. So when we're looking at this, we know that most of them are chlorine 35. So our answer should be quite close to 35. We have about a quarter of them that are 37, so our mass is going to be higher than 35, close to 35, but higher than 35. And we're going to see if that happens when we calculate it. So to calculate, you'll take your isotope times the percent, and we're going to put our percent into decimal form. To do that, you divide by 100, or I just move the decimal over 2 places. Okay, so divide by 100, or move the decimal over 2 places. And so I'm going to erase that right there. Okay, this number here, we have chlorine 35, and we have 75.42%. So you're going to move the decimal over 2 places, or divide by 100, same thing. And then you're going to take that decimal form of your percent and multiply it by the mass in the isotope. So 37 times 0.2447 gives me 9.053. 0.39. Now when I'm doing this, I'm not rounding to significant digits. I'm trying to find the mass of the element, and this is one of those rare instances where we will not round. Okay? We're not doing calculations with data collected in the lab. What we're trying to do here is find what is that full mass, that full decimal that you would see on the periodic table. And then our next one, we have chlorine 35. So multiply the 35 times 0.7542, which gives me a value of 26.397. At this point in time, you can add those up, and that gives me 35.45. Okay, and then when I look at the periodic table, I'll see that that matches up. This number might have been a little bit different. And if you're not given exact percents, that's common. Yeah, this gives me 35.4509. When you see these types of problem on your tests, it will be multiple choice. So what you want to do is pick the answer that's closest to yours. Now let's problem solve. So we said that most of them were isotope 35, so our answer should be close to 35. That checks out. It should be between 35 and 37 because those are the only two values that we have. And then because the 37 is going to bring the answer up slightly higher, the answer should be slightly higher than 35, which it is. Okay, so that's one way you can kind of check this as you're going through it. Now in this case we knew it was chlorine, but you won't always know the element, and you'll have to find it and then match it up to one of the elements on the periodic table, right? And it gave you a couple of other additional example problems to do along with a table that you can complete for practice.